Yes, my students. Last time I taught you about the work under the topic work and energy. This time our topic is energy. How you are going to define energy? Energy is the capacity of an object to do work. Okay? Energy is the capacity of an object to do work. First we are going right here. It is defined as it is the capacity of an object to do work. As the unit of work is joule, here also the unit of energy in SI system is joule, and the unit of energy in previous system is see, we know about so many types of energy, that is nuclear energy, electrical energy, solar energy, chemical energy, mechanical energy. Here we are going to study about the two types of mechanical energy, that is kinetic energy and potential energy. Here we are going to study about two types, the two types of mechanical energy. Okay, two types of mechanical energy. First one is kinetic energy, and the second one is potential energy. Okay, we are going to study about the kinetic energy and potential energy. The first one is here. We are going to study about the kinetic energy. Now see how we are going to define kinetic energy. If a energy is stored in an object due to its motion, is called the kinetic energy. For example, if we are going to switch on the fan, it starts rotating, and as soon as we switch off the fan, it does not stop immediately. It rotates for some time. While it's slow, it is due to the energy stored in the fan due to its rotation. Okay? Similarly, in the case of cycle, if you are going to put the pedal, it start moving. And but as soon as you stop the pedal, what happens? It does not stop immediately. It moves forward for some time. Why is so? Because due to the motion, energy is stored in the wheel of the cycle. Okay? And therefore it moves in the such energy stored due to the motion is called the kinetic energy. Here we are going to write. Now see, it is the amount of energy stored in an object due to motion is called kinetic energy. Okay? And its formula for the kinetic energy is half mv square, where m is the mass of the object, and v is the velocity. Okay. Now see, after this, we are going to find the expression for kinetic energy. Okay. Next topic is expression for kinetic energy. Now here first we will consider that an object of mass m is stationary or is at rest. Okay. Let an object of mass m is stationary. The second point. Therefore, therefore its initial velocity u is equal to 0. Now the third point, when a force F is applied on it produce an acceleration A. Therefore its final velocity after time t will be v. Fifth one, in time in time t in time t the distance covered will be okay. Therefore, in time t we cover a distance yes in the direction of force. Therefore, the work done will be here. The work done will be. Therefore, the work done W is equal to force into displacement. Okay. Now see here. According to according to Newton's second law, according to Newton's second law of motion, F is equal to me, where F is the force of light and m is the mass of the object, is the acceleration. Okay? And from the second equation of motion, S is equal to ut plus half a t square. Now, if you will see that object is at stationary position initially, therefore its velocity u is equal to 0 and s will become here 0 plus half a t square or s is equal to half a t. Now see here, if we are going to write its equation 1, this is equation 2, and this is equation 3, then from using 1, 2, and 3, what will be? We will substitute the value instead of f, we are going to write ma. Instead of s, we will write here half a t square. Therefore, the work done will be here half m a t a square. Okay. Now see, from the first law, from the first equation of motion, from the first equation of motion, from the first equation of motion. What is first equation of motion? That is V is equal to U plus AT. Here also the initial velocity is 0, therefore V is equal to 0 plus AT or V is equal to 8. Now, if we will substitute here, we is taking the square, sorry. taking the square of this, it will be v square is equal to a square t square. Substituting this value in the equation here, this is here, this is the fourth equation. Substituting this equation of yam, here we are having a square t square. Instead of this, we will write here of v square. This is the work done. But as you know that the work done on the object is equal to the kinetic energy gain. Okay? Is equal to kinetic energy gained by the object. Therefore, this kinetic energy is equal to work done or is equal to half m v square. This is the expression for the kinetic energy. Okay? This is the expression for the kinetic energy. After this, we are going to define the potential energy. Potential how we are going to define the potential energy? It is the amount of energy stored in an object due to its specific state or position. It's called the potential energy. You have seen that bow and arrow. If you are going to stretch the arrow on the bow, means its strike power increases. Okay? But if you are not going to stretch the arrow on the bow, what will happen? It will not have the power of striking. It will fall down. Okay? Therefore, there is energy stored in the arrow due to stretching it on the bow, and you can say due to the position of the arrow on the bow is called the potential energy. Similarly, if we are going to lift or carry an object on the surface of the earth, and if we are going to bring it upward, then what happens? The energy stored in this because we bring it from the ground to the height, certain height. And as soon as we will release it, it will move downward because it's having the potential energy. Okay, now here I'm going to write the definition of potential energy. It is the amount of energy stored in an object due to its specific due to its specific state or position is called potential energy. Is called potential energy. Okay, and potential energy is, is equal to mgh, where m is the mass, g is the acceleration due to gravity, and h is the height up to which the object is lifted. Okay, now we are going to find out here. Here we are going to find out the expression for potential energy. Okay. Now, first to carry an object, to carry an object of mass, yeah, of mass m to the height h from the surface of earth, from the surface of earth, a force equal to mg is applied to the opposite direction of gravitational force. And this work done, this work done for this work done is stored in the object as a potential energy. Okay. Therefore, the potential energy is equal to work done. And here work done is how much? Force into displacement. Force applied is, as I told you, to the weight of the object, and the displacement, suppose it's taken up to the ideals, will be mgh. This is the expression for the potential energy.